exponential function of base e, Naperian. Definition. The exponential function of base e, f, is defined by f of x equals e power x over minus infinity plus infinity. Consequences of the definition. The domain of definition of f, where f of x equals e power x, is R. Second, for every real number x, e power x is greater than 0. E power x is always positive because the base is 2.718 raised to any power, it should be positive. E power 0 is 1, e power 1 equals e power negative 1 equals 1 over e. Property 1. Let a belongs to R and b belongs to R. A and b are two real numbers. First, e power a times e power b, it's equal to e power a plus b. Multiplication of the same base e, we add the powers. E power a over e power b, it's e power a minus b. Similarly, we have e power a divided by e power b. Rules of powers, division of two numbers having the same base, e, so we subtract the powers. E power negative a, it's equals 1 over e power a. E to the power a to the power of b, it's e to the power a times b. Examples. Calculate and simplify. E power 2 times e power 3, the same base, we add the powers, e to the power 5. E to the power x all to the power of 2, it's e to the power x times 2, which is e to the power 2x. E to the power 3x plus 4 over e to the power x plus 2, we subtract the powers of the same base, so e to the power 3x plus 4, negative x, negative 2, so it will be equal e to the power 2x plus 2. Property 2, e to the power ln x equals x, for x always positive because we have ln x. Ln e to the power x is always equal to x, for x belongs to R. Examples. Calculate and simplify. E to the power 2 plus ln 3, we can split them to the same base, e to the power 2 times e to the power ln 3. E to the power ln 3 equals 3 multiplied by e squared. E to the power half minus ln 3, it's e to the power half times e to the power minus ln 3. From the properties of ln, we have e to the power half times e to the power ln 1 over 3. E to the power ln 1 over 3, it's 1 over 3, and e to the power half, we can replace it by radical e. Equations and inequalities. Let a belongs to R and b belongs to R. E to the power a equals e to the power b, then a equals to b. We can put ln to the both sides of the equations. So ln e to the power a equals ln e to the power b, so a equals b. Similarly, for the inequality, e to the power a greater than e to the power b, then a greater than b. E to the power a less than e to the power b, then a less than b. Examples. Solve the following. Part A. E to the power 3x plus 2 equals e to the power 5. Since we have e on both sides, we have to take equal powers. 3x plus 2 equals 5. Solve the equation, then x equals 1. Part B. E to the power x plus 3e to the power negative x equals 4. Since we have e to the power x and e to the power negative x, we can multiply both sides by e to the power x. So the second step, e to the power x into e to the power x plus 3x e to the power negative x equals e to the power 4x. We distribute, then we get e to the power 2x minus 4e to the power x plus 3 equal to 0. Change the equation into quadratic by taking e to the power x equals a, where a positive. E to the power 2x minus 4e to the power x plus 3 equals 0. So it's a squared minus 4a plus 3 equals 0. Solve the quadratic using calculator, then you get a equals 1 and a prime equals 3. Then replace a by e to the power x equals 1. Then solve, you get x equals 0. E to the power x equals 3. Then x equals ln 3. Part C, e to the power x minus 1 greater than or equal e to the power negative 2. We have the same base e, then take the powers. X minus 1 greater or equal negative 2, then x is greater or equal negative 1. E to the power x less or equal to 2, we can take ln on both sides, then we have x less or equal to ln 2. Derivative of a natural exponential function. The exponential function of base e to the power x, defined over r. It has a very special derivative, which is f prime is e power x itself. We can have exponential function of base e where f of x is e power u, where u may be a polynomial or a rational or any function which is defined. This e power u is defined over r. The derivative of this function f prime of x, it's equal to u prime e power u. Examples. Find the derivative of the following function. The first function f of x e to the power x squared plus 3x. So u is x squared plus 3x. U prime, it's 2x plus 3. So f prime of x equals 2x plus 3 times e to the power x squared plus 3x. The second one, f of x equals e to the power x over x squared plus 1. This is a rational function where the numerator is e power x and the denominator is x squared plus 1. So we have to use u prime v minus v prime u over v squared. So f prime of x equals u prime, which is e power x, times the v, which is x squared plus 1, minus v prime, which is 2x, times the numerator e power x, over the denominator squared, which is x squared plus 1 all squared. We can take e to the power x common, then we have x squared minus 2x plus 1, which is an identity, x minus 1 all squared multiplied by e power x, divided by x squared plus 1 all squared. Limits at plus or minus infinity. Limit as x goes to negative infinity e power x equals 0. Limit as x goes to positive infinity e power x equal plus infinity. Limit as x goes to plus infinity e power x over x equal plus infinity. To calculate such a limit, if we calculate limit as x goes to positive infinity of e power x, it's positive infinity over positive infinity, then it's indeterminate form. We use L'Hopital, do a derivative, then we get limit as x goes to positive infinity of e power x, which is positive infinity. Fourth limit as x goes to plus infinity e power x over x power alpha, where alpha is a positive rational number, it's positive infinity. Alpha could be 2, 3, half, any positive rational number. Limit as x goes to minus infinity, x times e power x is 0. Limit as x goes to minus infinity, x power alpha e power x, where alpha is a positive rational number, it's also 0. The fourth limit and the last limit, we can take only the limit as x goes to positive infinity of e power x, which is positive infinity, or limit as x goes to minus infinity of e power x, which is 0. We can say that calculating such limits, e power x takes over x. Study of the function f of x equals e power x. Consider the function f defined over r by f of x equals e power x. Designate by C its representative curve in an orthonormal system. Limit as x goes to minus infinity of e power x equals 0. Limit as x goes to positive infinity of e power x is positive infinity. Therefore, we can deduce from the first limit that C admits a horizontal asymptote of equation y equals 0, which is the x-axis. Derivative of f of x, f prime of x equals e power x, which is always positive for all values of x. Therefore, f is strictly increasing over r. We can set a table of variations from minus infinity to plus infinity. F prime is always positive. It's strictly increasing from 0 to plus infinity. The curve should be drawn above the x-axis. Now the x-axis is a horizontal asymptote. It's passing through 0, 1. The image of 1 is e, which is 2.718. So, and the function is always above the x-axis and is strictly increasing. Thank you.